Hi everyone and welcome to this video about the laws of logarithms. Before we begin this video, please remember to like and subscribe if you enjoy it. You can always comment down below any questions you might have about the video, and if you would like me to make a video on another maths topic, please feel free to leave that in the comment section down below. I'm going to show you where each of the laws come from, recap the laws, and then we'll go through some practice questions. Let's start with the multiplication law. For all of these laws, it's important to remember we require logarithms with the same base. Let's take our two logarithm expressions, log to the base a of x, and set that equal to m. Let's take another expression, log to the base a of y, and set that equal to n. I can now rearrange both of these expressions, so I can have x equals a to the power of m, remembering the inverse of a logarithm to the base a is on both sides place a as the base of an exponent. I can do this for the other expression as well, so y equals a to the power of n. Let's take x and multiply it with y. The corresponding expression written using a, m, and n would be a to the power of m times by a to the power of n, and we know that we can rewrite this using our laws of indices. So that would be a to the power of m plus n. Taking this expression, we can then do the log of base a on both sides. Remembering that m and n are our original logarithm expressions, we can finally write this as log to the base a of x plus log to the base a of y. So we can see that within logarithms with the same base, if we are multiplying two numbers together, the expression can be rewritten as the addition of two logarithms. We can do something similar with the division law. We can take the previously defined logarithms, and in this case calculate x divided by y. So we would have a to the power of m over a to the power of n, and using the laws of indices, we see that's a to the power of m minus n. Taking a logarithm to the base a of both sides, and resubstituting our initial logarithms, we can see that a division within a logarithm can be rewritten as the difference between those two logs. The final law to remember is the power law. This one is quite simple to prove. Let's say we have log to the base a of x to the power of k. We can replace x with this expression here, remembering that base of a raised to the power of log to the base a simply cancels out. So the initial expression can be rewritten like this, and using our rules of indices, we can bring the k into the power. So we have k multiplied by log to the base a of x. Now we remember that log to the base a and having a at the base will cancel. We see that this expression becomes k log to the base a of x. So in effect, our initial power of x has just been moved down to the front of our logarithm. So to summarize, here are the three laws that you will need to remember in order to manipulate logarithms. We have the multiplication law, the division law, and the power law. These will not be given to you in an exam, so you should do your best to remember them. There are also some special cases which we should remember as well. Log to the base a of 1 over x can be rewritten as log to the base a of x to the power of minus 1. Using our final power law, we can bring the minus 1 to the front, so it just becomes minus log to the base a of x. Another rule to remember is that log to the base a of a is of course just 1. And finally, log to the base of anything applied to 1 is going to equal 0. Let's take a look at these two examples. For part A, we can just use our multiplication law. We see that the base of the log is the same in both expressions, so this becomes 6 times by 7 within our single log, so we have log to the base 3 of 42. For the second part, we can't combine logs if there are numbers being multiplied in front of them, so we have to first use the power law to remove those. Now we can use the multiplication law in order to combine the logs. And our final answer will be log to the base 5 of 72. Let's take a look at this log equation together. So on the left-hand side we have these logarithms which are stopping us from solving this equation easily. In order to remove a logarithm on one side of the equation, we must raise both sides to be the power of the same base number. In this case, we would need base 3. Except if we were to just take the whole of the left-hand side, place it as the exponent of 3, we wouldn't have simplified it, because the logs would not cancel out with that base immediately. So what we have to do is first apply our laws of logarithms. Here we can use the division rule. And now when I have one logarithm on one side of the equation, I can then do my base of 3 on both sides. Now this is just a linear expression that we can quickly solve. And there's my final answer. Let's look at a final example together. So here I have 2 in front of my logs. I know I'm not going to be able to solve anything if that remains, so I'm going to divide both sides by 2. I now need to have my logarithms on the same side of the equation in order to apply the laws of logs. Now applying the division rule and raising things to be the exponent, we now have a linear equation that can be solved simply. And here I'll get my final answer. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I'll see you in the next video.